All right, Chapter 6, Section 1. This is the last part of the section. Gauss-Jordan elimination. We continue the process of getting a matrix with ones down the diagonal, but we now need to get zeros in every position both above and below each one. So the Gauss elimination was getting the zeros below the ones, and Gauss-Jordan, we're now going to do the same thing. Use row operations to get the zeros above the ones. This type of matrix is said to be in reduced row echelon form. Reduced row echelon form. Okay, our box information. Solving linear systems using Gauss-Jordan elimination. First, we do like we did before and write the augmented matrix for the system. Use matrix row operations to simplify the matrix to one with ones down the diagonal from upper left to lower right, and zeros above and below the ones. What do we do first? Well, the first step is to get a 1 in the upper left-hand corner. Then we use that 1 in the first column to get the zeros below it. Then get a 1 in the second row, second column, and use that 1 in the second column to make the remaining entries in the second column 0. Get a 1 in the third row, third column, and you keep doing that. And use that 1 to make the remaining entries in the third column 0. Continue this procedure as far as possible. As far as possible. Next thing we do is use the reduced row echelon form of the matrix in step 2 to write the system's solution set. Back substitution is not necessary. So on a quiz, you would have to first put a matrix in row echelon form, use back substitution, give the solution. The next step would be to recopy your row echelon form matrix, put it in reduced row echelon form, and write the system solution a second time. All right, so we are going to pick up with the row echelon form in example 3. It says, solve the system in example 3 using Gauss-Jordan elimination. Begin by working with the matrix that you obtained in example 3. Well, the matrix that we obtained in example 3 was 1, -2. Oops, sorry, -1. 2 bar 9. Let me clean that up a little bit. All right, so it was 1, -1, 2, 9. The next row was 0, 1, -2/3, 0, 0, 0, 1, 3. Okay, so we started by getting a 1 up here. We used this 1 to get those zeros. Next thing, second row, second column, we get a 1. Use that 1 to make that be a 0. Third row, third column, we got a 1. The matrix is in row echelon form with 1s down the diagonal and 0s underneath. We're going to continue to put this in reduced row echelon form. Now you want to start by making this entry right here in the first row, second column. We want to get that to be a 0. Okay, so we're working these left to right. You went left to right for the zeros underneath. And then we got to come back here again from left to right to get the zeros above. All right, so what could I do? What row operation? Well, if I add rows 1 and 2 and replace row 1, that will give me a 0, right? -1 + 1 is 0. So I'm going to say for my workspace, row 2 plus row 1 gets replaced. All right. Row 2, 0 plus row 1, 1. Remember, I'm not putting anything here because row 1 is getting replaced. 1 plus -1, 0. -2/3 plus 2. Well, you have to convert 2 to thirds. That's 6/3. So -2/3 plus 6/3 is 4/3. Now, when you're adding 2 rows, I don't expect that you're going to show the work. But if you're doing something like multiplying and then adding, you should have the work in there. Now, look, row 2 plus row 1. 0 plus 9 is 9. None of the other rows change, so I'm going to copy them. Now, we're going to use this 1 on the bottom, if necessary, to make that be a 0 and that be a 0. Well, both rows 1 and 2 are going to change. We just have to figure out what operation to make it change. All right, I'm using the 1 to make this be 0. So if this 1 is -4/3, and then I add it to row 1, I'm going to get a 0. So that means -4/3 times row 3, add it to row 1 gets replaced. How do I make this entry become a 0, this -2/3? I'm going to multiply this 1 by +2/3 and add it to row 2. Row 2 gets replaced. 2/3 times row 3 plus row 2. Row 2 gets replaced. Now, row 3 is not changing. All right, it doesn't matter what we do. I'm just going to do this row because I have the operations. 2/3 times 0, rather this one here because I'm multiplying by row 3. 2/3 times 0 is 0 plus row 2 is still 0. 2/3 times row 3. 2/3 times 0 is 0 plus 1 is 1. 2/3 times 1 is 2/3 plus -2/3 is 0. And that's why we did this. All right, 2/3 times row 3. Well, 2/3 times 3 is what? 6/3, which is 2. And 2 plus 0 is 2. Do the same thing here. -4/3 times row 3. I'm over here. That's 0 plus row 1 is 1. -4/3 times the entry in row 3 is 0, plus the entry in row 1 is 0. -4/3 times 1 is -4/3, plus 4/3 is 0. That's why we did it, to make it become a 0. All right, and finally here, -4/3 times this entry in row 3 is -4. -4 plus 9 is 5. And now notice your matrix has 1s down the diagonal, 0s below and above. We conclude from this matrix that 1x, 0y, 0z equals 5. So x equals 5. No x, 1y, no z, y is 2. No x, no y, 1z, z is 3. So my solution in set notation, make sure you're putting set notation, and make sure that you are writing an ordered triple or an ordered quadruple if this is a system of 4. Final answer is 5, 2, 3. Coming right from the system of the row operations that we use in the matrices. Okay, so pretty much the same. You're still using the 1 to get the 0. This time you have to work up instead of below. You got to do the below first, and then you work up. It's always left to right. You use the 1 to get the 0. Let me know if you have any questions. Have a great day.